Yo, welcome to video number 47. This video is on sequences. Now I've got a few keywords here for you. Now arithmetic is a type of sequence where you are adding or subtracting to get the next number. Geometric is another type of sequence where you are multiplying or dividing to get the next number. Fibonacci is another type of sequence where you are a special one, where you are adding the previous two terms to get the next one. A term is just a number within the sequence. Term-to-term rule is how you get from one number to the next. So what is the term-to-term rule? It's add 2 or it's multiply by 5 or whatever. And then a difference is obviously the difference between the term numbers, but it's basically the one number take away from another. That's how you find a difference in maths. Now, the method states to find the next number in a given sequence, you will need to be able to spot patterns. That's what you need to be good at, right? The difference will be arithmetic, adding or subtracting, or it will be geometric. It could be a special type of sequence known as the Fibonacci sequence, which, like I said, involves adding the previous two term numbers to get the next one. I already mentioned it, but it is worth mentioning twice. Now you should have it firmly fixed in your brains. You might be able to spot one of these questions that I've written in this first box here. So number one, find the next two terms in the following sequence. Let's try this. Let's see if we go from 5 to 8. What's the difference between 5 and 8? 8 take away 5 is 3. So we're going to go plus 3 to get from 5 to 8. Plus 3 gets us to 11. And plus 3 gets us to 14. We have decided that is most definitely an arithmetic sequence. And we will be adding 3 to get to the next number. Right, and that would give us 17. And then if we add 3 again, we will get to 20. Okay, pretty simple. Now we start in B at 14. Let's see if we can take away 2 to get to 12, and we can. And we take away 2, and that works again to get to 10. And if we take away 2, it works again to get to 8. So let's go and get 6 and then 4. All right, there's very, very easy stuff, isn't it? Now in C, this is the one that you might have spotted already. Fibonacci, you got 1 plus 1 is 2, and 1 plus 2 is 3, and 2 plus 3 is 5. 3 plus 5 is 8. So adding the previous two will get you the next term number. 5 plus 8 is 13. And then 13 plus 8 is 21. Okay, and there is our Fibonacci sequence. It is the Fibonacci sequence. You see it in nature, and it's a beautiful thing. Beautiful mathematical thing that you can actually observe with your own eyes every day. In question 2, you've got to find the term-to-term rule and the next two terms for each. So let's have a look at the first one. You've got 4 and then 8. Now, can you add 4 to get to 8? Yes, you can. But is it that? Because that would have to work for the next one. Now, 8 plus 4 does not equal 16, so it cannot be an arithmetic sequence. All right. I would always go there. My default is, can you add or subtract, right? So this, we're going to find another way of getting there, and now another way of getting there would be to multiply by 2, right? This is what we call the common ratio, if it is a multiplied by 2 all the way through. It looks like it's going to be, doesn't it? So we take this 8, we multiply by 2, we get 16. Take the 16, multiply by 2, and you do get 32. So all we need to do is multiply the 32 by 2, and that'll give us 64. Fancy little 6 there, wasn't it? And then multiply that by 2, and we get 128. Okay. And that should make perfect sense. But it's a little bit trickier to find, isn't it? Sometimes people will be like, oh, it didn't work, couldn't add, right? But you just multiply instead. Geometric sequence. Now 54 is our starting point here. And yeah, you guessed it, we're not going to be able to take away something here. So we're going to divide by 3. All right, 54 divides by 3 to get you 18. 18 multiplies by 3 to get 54. So we're dividing in this one. And does that work again? Yes, it does. 18 divides by 3 to get 6. So if we take 6 and we divide it by 3, what do we get? We get 2. Okay, and then if we take 2 and we divide it by 3, let's just write that in there. 2 divided by 3 is actually 2 over 3, 2/3. That's our simplest way we can write that one. Okay, so you might get a question like that, and you do get a fraction. Just write it as a fraction. You don't have to worry about changing into a decimal or anything, right? Now in C, we've got 1, 3, 6, 10, 15. This is another special type of sequence actually that I've included here. Let's find the difference between each of these. So the difference between 1 and 3 is 2, so plus 2. So we're adding on 2 there. Then we're adding on 3. Then we're adding on 4. And then we are adding on 5. So yeah, you guessed it, there's a pattern going on. 2, 3, 4, 5. We're going to add on 6. Okay, if we add on 6, we get to 21. All right, and then we add on 7, because that would follow the pattern. All right, and that would give us 28. Now this is the triangular numbers sequence. All right, and this is one that you can learn as well. You're just adding on an extra one every single time you go through the pattern, through the terms. Okay, so I'm going to move myself over here again, as I always do, for the third question. And this one is an absolute beast of a question. Love this. I love these sorts of questions. They're amazing. They're beautiful, right? But you may not agree. The first term in a Fibonacci style sequence is 5, and the fifth term is 31. What are the 3 term numbers in between? So I would set this up as 5 at the beginning, and then something, 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 and then the last number is 31. All right. Now this is pretty awkward. All right. It is pretty awkward. Let's take this first value here to be a letter. All right. Now, anytime you don't know something in the world of math, you can always represent it with a letter. All right. And now we do know something about Fibonacci style sequences. All right. As I've mentioned 3 times, I think, in this video already. If we add the previous 2 terms, we get the next one. So we can write an expression or form an expression for each of these 3 missing numbers, which we can then turn into an equation and solve. All right. It's a beautiful type of question. So top end, this would be grade 5 rather than grade 3. All right. I think anyway. So we got 5 plus something, and I'm going to make that something x. All right. It doesn't matter what you make. You can make it anything you want. You make f if you want for Fibonacci, right? So 5 plus x is 5 plus x. All right. That's our next term. 5 plus x is the only way we can write it is 5 plus x or x plus 5, right? But 5 plus x. And then we've got x plus 5 plus x. This term, second one, plus the third one will give us the fourth one. All right. So you got x plus x is 2x, and you got that plus 5 there as well. Okay. So now we've got an expression for each 3 of those terms, right? And then remember, we've got to add the third one and the fourth one to equal the fifth one. All right. So I'm going to write this down quite a long way. So 5 plus x plus, and I'll put that in some brackets there just so you know that this is this term in the middle. And then you've got the 2x plus the 5. All right. And that equals the 31. All right. We are adding, and if I put some term numbers above these things, term number 1, term number 2, term number 3, term number 4, and term number 5, right? We are adding term number 3 to term number 4 to get term number 5. Okay, and that's our Fibonacci style sequence. All right, and it all started with us deciding to represent this first unknown here with a letter. Any letter of your choice. So I'm going to collect all this together and form a simple equation. So I've got 3 x's, because x plus 2x is 3 x's. And I've got 10, because I've got 5 plus 5, so plus 10, is equal to 31. Right, solving the equation, and this is a 2-stepper, so if you're not sure what to do, watch the 2-step equations video. I'm not going to show all the work in here. Take away 10 from both sides is 21, 3x is 21, x equals 7. Divide both sides by 3, and x equals 7. I have found that that number, the second term number, is 7, okay? And I might just write that that's the second term number, the third term number, and the fourth term number. All right, so the 7, and then I've got 5 plus 7, which is 12 for the second one. And then I've got 2 times 7, which is 14, plus 5, which is 19. Okay. No, it's not. It's not. It's not 19, is it? What am I talking about? So that is 7 times by 2, which is 14, plus 5. Yes, it is 19. What am I talking about? Of course it's 19. Anyway, I got completely confused then. Anyway, that's a beautiful, beautiful question, and you can always just check that 12 plus 19 does make 31, and of course it does. I had not made a mistake, which is good because it's the end of the video, and I don't want to do it again. All right, I've gone through everything. And that is a lovely, 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 difficult mathsy question to do with the world of sequences. All right, so just to show you how difficult it can get. Hope it made sense. Please continue to like and subscribe and spread the word about this Bear Maths YouTube channel, because it can only help people in the long run, can't it? Fingers crossed. All right. Cheers. See you next time.